What's up, ladies and gentlemen? Today we're going to be going over lecture 3.7, moles to particles. This was a short one, but it's an essential one. So stay focused. We'll get to this in no time. Today we got one learning target. We want to be able to take any elements and convert between the number of moles of that element we have, or compound, to the number of particles, and back. So, first things first, let's talk about what we're dealing with. We want to be able to convert moles and particles. How do we do that? Pretty simple. Our focus for today is actually looking at from moles to particles. Now we've gone from moles to grams, and what we use here is the conversion factor, which you guys have become very familiar with. It's known as molar mass. But there's a new one today that we're focusing on, right in here. And this one is going to take us from moles to particles, and particles back to moles. So let's talk. How's it work? We need to know Avogadro's number to be able to do any of this. And Avogadro's number, essentially, this famous Italian chemist just said that for any 1 mole of anything, it could be any element, compound, whatever it is, 1 mole of that contains 6.022 times 10 to the 23rd particles. You don't need to know why, you just need to know that it is. So basically we can use this. We can say that there is for every 1 mole, we have 6.02 times 10 to the 23rd particles, whatever it is. So the conversion factor looks like this. 6.022 times 10 to the 23rd particles over 1 mole. And we can flip this if we need to, if we're going back from particles to moles. So let me give you an example. Say, for instance, that you react 3 moles of HCl. How many moles did you react? Well, you start, of course, with the 3 moles you're given. So we know we have 3 moles of HCl. And we're always going to multiply that by what we want over what we have. And in this case, we want molecules. And we have moles, which both are going to end up canceling out. So for every 1 mole, how many molecules or particles do I have? The answer is 6.02 times 10 to the 23rd. And boom, I have my equation. So it's going to be 3 times 6.02 times 10 to the 23rd. And there we are. Now, the rules of multiplication are that we don't have to do anything in a specific order. So what I'm going to do is I'm going to multiply 3 and 6.02 together. It's going to look like this. 6.02 times 3, which is going to give me 6, hold on, 6, 0, 18. And since there's 2 decimal places, boom, boom, 18.06 times 10 to the 23rd. Now I know that's screen changed, so let me fix that really quickly. Sorry about that. That should fix the problem. So we end up with 18.06 times 10 to the 23rd, and the only thing we have left are molecules, because the moles cancel out. So I end up with 18.06 times 10 to the 23rd molecules. Unfortunately, that is not the completely correct answer, because in scientific notation, you can only have 1 number in front of the decimal. So I'm going to take this decimal, move it 1 place to the left, and subsequently change this 23 into a 24. The answer is 1.806 times 10 to the 24th molecules of hydrochloric acid, or HCl, the acid in your stomach. Hope that's helpful. Now I want you guys to give this one a shot right here. If you react 4 moles of MnO2, how many particles of MnO2 did you use in this reaction? Same thing, give it a shot. Once you're finished, you guys can proceed on to this one right here. Now we're going in reverse direction. Let me show you how to start this one off. You're going to start off by taking what you have, 24 times 10 to the 23rd particles of MnO2, writing that down as always. 24 times 10 to the 23rd particles of MnO2. Multiply it by, well, that's not right. Multiply that by what you want over what you have. And replace that with the appropriate conversion factor and end up with moles of MnO2. If you can get that, you're pretty much good to go, but there's one more challenge problem that I want to present you with. And now we're going to take this little guy right here, this little graphic organizer, we're going to go all the way from grams to moles, all the way to particles. So here is our problem. If you react 25 grams of MnO2, how many particles did you use? And I'm going to start you off by saying 25 grams of MnO2 times this and times that. So there's two conversion factors. You're going to end up with particles of MnO2. Good luck, ladies and gentlemen, and once you're done, that is it for our class today. Make sure to summarize for me, get your note-taking and homeworks done, and start your wiki spaces for Unit 3. That's it for me, guys. Homework 3.7 on moles and particles. I hope this helped.